numerical. Another question, they can give you the working principle of MOSFET or the construction of MOSFET, or they can give you any derivation. Generally they'll ask you calculate the drain current derivation. Okay, so let's focus on the numerical, because numerical will get 100, like there is a 99% chance that you will get the numerical based on MOSFET. First of all, what is MOSFET? Basically, MOSFET stands for M for metal oxide semiconductor field effect transistor. Okay, so this one is the MOSFET. It's a kind of transistor which is used to control the flow of current. Okay, clear? Basically it is used to control the flow of current. Earlier we have studied about the diode. Is just behave like a switch. It can be on or off, but MOSFET can be used to control the current. And what is the symbol for the MOSFET? Like it will have three terminal. One of the terminal is source. Okay, sorry, one of the terminal is source, that is denoted by S. Another of the terminal is drain, that is denoted by D. Another of the terminal is gate, that is denoted by G. Gate is used to control the flow of amount of current. Source, from where we are getting the current. Drain, where current is moving. As I told you also earlier, like suppose this is our tap, right? Here the water is collecting in the tap, so this one is the drain, where water is collecting. From where the water is coming inside the tap, that one is the source. From the source water is coming, and from where we can control the flow of water, that is through gate. Okay, clear? So basically MOSFET is divided into two category. One is the enhancement type MOSFET, and another one is the depletion type MOSFET. Got it? Now see, first of all, the formulas based on MOSFET. Generally you will use ID. ID stands for drain current. Okay, is equal to half into mu n COX W by L VGS minus VTH का whole square. See what is VGS over there. VGS is the gate to source voltage. Okay, what is VTH over here? VTH is the threshold voltage. What is W over here? W is the width, L is the length. 99% of the time they'll give you this value W by L exactly. Okay, next one, mu and COX is the constant. They'll give it to you every time. This is one of the formula and very important formula. Another formula of this one is VDS is equal to VDD minus ID into RD. What is VDS? That is drain to source voltage. VD is the drain to drain voltage. ID is the drain current, and RD is the drain resistance. Got it? Next one formula is VDS is equal to VGS minus VTH. So mainly you need to use these formulas in your MOSFET. Note it down. Basically in this kind of question you need only two formulas, half mu n COX W by L VGS minus VTH का whole square. So half we know, mu and Cx we know, W by L they have given, VGS is 1 volt, VTH is given for 0.4. Now they are asking RD. For RD the formula is VDS is equal to VDD minus ID into RD, right? VDS value is how much? That is VDS minus VTH. That value we know, VDD value we know, ID we have calculated from this case, RD value we can get it. So every time Manipal में इससे बाहर you will not get any question related to the MOSFET. Okay. Now MOSFET numeric formula is completed. Next topic you will get it based on opamp. Opamp में I told you types के question आते हैं. Either they'll give you not is equal to like 1 plus 2 minus 6v3. You have to draw the opamp circuit, or you will get the question of expression of derivation of either inverting amplifier, non-inverting amplifier, or summing amplifier. So you must remember the derivation formulas. Other question they can give you the based on CMRR, right? So let's see the formulas first for op-amp. As I told you, the very first type of amplifier is the inverting amplifier, right? In the inverting amplifier, the voltage is connected to the negative terminal, positive terminal is grounded, input resistance is R1, feedback resistance is RF, voltage is V1, output voltage is V0. So its formula is V0 is equal to minus RF by R1 multiplied by V1. Minus sign because it is connecting to the negative side, and its V1 is the input voltage, right? Next one is the non-inverting amplifier. In the non-inverting amplifier, draw the op-amp. Now in this case, voltage is connected to the positive terminal, right? Let's take like this. And feedback is always connected to the negative terminal only, always. RF, this is resistance R1, and voltage we are providing the positive terminal. Got it? So this is V0. In this case, V0 formula is 1 plus RF by R1 V1, where V1 is the input voltage, RF is the feedback, and R1 is the input resistance. Got it? Now the case next case that is based on inverting summing amplifier. Okay, in your syllabus there is only inverting summing amplifier, there is no non-inverting summing amplifier. Okay, so as its name suggests, summing means adder, it is adding something. So adder means we are connecting the voltage, the again it's an inverting, so voltage would be connected to the negative terminal, positive terminal is grounded, and you can assume that there is a three resistance, two resistance, it should be more than one for addition, right? So it would be R1, correct, and then R2, then R3, voltage is V1, and feedback resistance by RF, output voltage is, so V0 formula is not is equal to minus RF by R1 V1 minus RF by R2 minus RF by R3 is the formula. Clear? Any doubt up to here? Now if the value for RF, R1, R2, R3 all are equal, so RF equal to R1 equal to R2 equal to R3, then in that case what would be the output voltage? That is minus of V1 plus V2 plus V3, right? That's why they called it as adder. It is the addition of voltage. It is an inverting, voltage is connected to the negative, that's why we got it as a negative sign. Okay, understood? Now the next case is difference amplifier. Difference amplifier पे generally question नहीं आता, but still I am telling you the formula. In the difference amplifier, again the feedback is connected to the negative term and the input resistance is R2. मैं ये सारी चीजें याद रखनी. Okay, this is V, positive terminal is R3, and then it will be R1, this is V1, and output voltage is denoted by a V naught, right? This one terminal is grounded. So in this case, V naught formula is, it is the like big formula. Naught would be equal to how much? 1 R3 divided by R1 plus R3, then 1 plus RF by R2 minus RF by R2. Got it? This is the output voltage formula for the difference amplifier. Next one will have integrator. Integrator पे कभी कभार क्वेश्चन आ जाता है, like there is 6 chance. So integrator में will use capacitor. Positive terminal is grounded. Input resistance है and capacitor है. Okay. So here the V is the input voltage, resistance है, capacitor है, and V naught. There is a formula V naught equal to minus 1 by RC. Integration है, integrator है तो integration will use in of dt. Got it? Now इस केस में कभी कभार they can ask you the waveform. वेवफॉर्म देखो कैसे बनानी है, हर बार सेम बनानी है, कोई भी वेवफॉर्म पूछ यही बनानी है, याद कर लेना. लाइक इट इज फॉर कैपेसिटर, पॉजिटिव साइड पे है, देन इट इज मूविंग डाउनवर्ड, देन इन दैट केस एनर्जी इज डाउनवर्ड. ऊपर जा रहा है तो एनर्जी इज इन, देन डिक्रीज, देन इंक्रीजिंग, देन डिक्रीज, लाइक सो. तो इंटीग्रेटर का वेवफॉर्म इफ दे विल आस्क यू विल गेट इट एवरी टाइम द सेम. यहाँ पे +5 वोल्ट है तो ये भी मैक्सिमम कितना जाएगा? +5. ये -5 है तो ये भी कितना जाएगा? -5. क्लियर? नेक्स्ट वन इज द डिफरेंशिएटर. डिफरेंस बिटवीन द इंटीग्रेटर एंड डिफरेंशिएटर इज negative, positive. Positive terminal is grounded. In the negative terminal, and this one as the input. So V equal to minus RC, differentiation by, as you know, RF. Next I told that they'll give, right? They are saying that it means the ability of opamp to reject signals common both input terminal. Okay, basically what they want to say, the signal common towards the both the input, that is generally noise. The signal which is common to both negative and positive, that is noise. So it rejects the noise and it won't allow the noise to move the output side. Clear? So we'll have formula based on that. CMRR is equal to AD by ACM, where AD is the differential gain and ACM is the common mode gain. So for that, if we want CMRR in decibel, sometimes they'll ask you to calculate CMRR in decibel. For that, formula is 20 log base 10 AD by ACM. So they can give you AD and ACM in the direct way or in the indirect way. They can give you the output voltage. So what is the formula for the output voltage? That is AD AID plus ACM into I. Okay, AD, as you know, AD is the difference the two voltage, that will be V1 minus V ACM as it is. ACM is the common mode gain of the opamp, so it would be V1 plus V2 by, this is the formula for V0. Note down this thing. Now the last category of the opamp, that is V0 is equal to 3V1 minus 6V plus 9V3. They'll give you the question like this, and they said that you need to draw the opamp circuit. Now see, in this case two signs are same, this one and this one, right? So draw two opamp first, like negative positive one is grounded, again negative positive one is grounded. Now these two are having same sign, so we can combine it. Okay, so it would be here V1 and V3, because इनका sign positive and इसका sign positive. What would be the resistance? In these cases we need to assume RF would be equal to 10 kilo. If they have given, then it's well good. If they don't give, then in that case we need to assume 10 kilo. So for V1 it would be 10 by 3, for V3 10 by 9. Okay, clear? Now as you know, feedback resistance is 10. Now we mark this one, like we solve this one part, that is 3V1 plus 9V3 minus 6V. So we simply write it here as minus of minus 3V1 minus 9 minus 6V2. This green portion we have solved. This one is like this. Now we need to combine it with the V2, right? So for that, like this would be the resistance. One V2 also we need to add it. So this would be R2. This would again the feedback resistance RF, that is how much? 10 kilo ohm. So it would be 10. R2 कितना होगा? That is 10 by 6, and this would be 10 only. Okay, so this is the circuit diagram for the two kind of op-amp. एवरी टाइम मणिपाल में यही पूछते हैं कि दो पॉजिटिव साइन है एक नेगेटिव साइन है, तो जो पॉजिटिव साइन है उसको एक साथ, जो नेगेटिव वाला है उसको अलग से कंबाइन करके. इफ आई कंपेयर इट विद द स्टैंडर्ड इक्वेशन माइनस आर एफ बाई आर वन वी वन माइनस आर एफ बाई आर टू आर थ्री वी थ्री, तो माइनस की जगह माइनस है, माइनस की जगह माइनस है, तो इट वुड बी अ इन्वर्टिंग समिंग amplifier, right? Similarly we'll have minus 6v minus 6v2, and this one combined it with minus of v, तो ये क्या बन गया? minus vx minus 6, it is also an inverting summing amplifier. तो vx यहाँ से combine कर दिया, ये vx आ गया, v2 उसमें add कर दिया. So this is your final circuit diagram. याद करना है याद कर लो, मतलब this is the concept also I told you, and the diagram also. Now see the numerical based on this rectifier. First of all we are doing the topic based on rectifier. It's a simple question and 4 marks का question है. The standard equation is, as I told you, V is equal to V max sine omega t. Omega is 2 pi ft. So V is the given 20 sine of 2 pi 50 t. So from here we can get the value, that is V max is how much? 20, and frequency is how much? 50 hertz. Load resistance RL they have given 1 kilo ohm, right? Now this is for the full wave rectifier. FWR means full wave rectifier. Now they are asking to calculate the I average. I average formula is how much? 2 I max by pi, correct? But we don't know I max, we know V max. As you know, according to Ohm's law, V DC, or we can say V max is equal to I max into RL, right? This is the formula. So for that we know we are having another formula, VDC is equal to IDC into RL. So VDC is how much? V average. V average is how much? 2 V max by pi. IDC is how much? 2 I max by pi, or we can directly write down IDC. RL value we know 1000 ohm. So can we substitute in this and then can we get the value for IDC or I average? IDC and I average is same. So Vmax is how much? 20. We can substitute in this formula, that is 2 Vmax divided by pi is equal to IDC into RL, right? Next they are asking IRMS. So IRMS is how much? IRMS is equal to Imax divided by root 2. So Imax ka from, we can get it Imax from here. If we know IDC, then we can get Imax also. Imax we can substitute it here. Next they are asking the efficiency. For the full wave rectifier efficiency is 81.2%. Okay. As I told you, the formula is also now for this one. See, IDC formula, IRMS formula, for all this. You need to learn all these formulas because no formula is given in your handbook, right? Now in the next case they are asking the efficiency. So efficiency formula is this one. RL is the diode resistance, correct? Next we need to calculate the ripple factor. Now see what is the formula for the ripple factor. Ripple factor का formula I am writing here only. Ripple factor का formula is, ripple factor is denoted by gamma and its formula is form factor का square minus 1, means kf का square minus 1. So for that you should know the value for the form factor also, कि form factor का formula, right? Now see what is the formula for the form factor. Form factor is denoted by kf and its formula is IRMS by IDC. For all the cases, either it would be half wave rectifier or full wave rectifier. Similarly, we need to calculate maybe the peak factor. Peak factor ka formula is denoted by Kp. It is maximum value divided by RMS value. Okay. Again, it is same for half wave rectifier and for full wave rectifier. Now you already calculated RMS in the question, right? You already calculated IDC in the question, then you will get form factor. So now you need to calculate ripple factor, that is kf ka square minus 1. Clear? Can you get it now? The ripple factor as well. So see, 4 marks का question है, 1 for average, 1 for RMS, 1 for efficiency and 1 for ripple factor. इस टाइप का क्वेश्चन मणिपाल में बहुत फ्रिक्वेंटली रिपीट होता है, राइट? सी द क्वेश्चन. VDC है, VDC formula is 4FCRL multiplied by VM. We need to calculate the value for capacitor. VM is, VDC is 2 Vmax by pi, right? We know VDC, तो Vmax आ जाएगा. Now tell me RL, how can we get the value for RL? RL is the load resistance, so VDC is equal to IDC into RL. We'll have this formula. VDC is equal to IDC into RL. VDC is 5, IDC is 10 into 10 raised to power minus 3. From here, can we get the value for RL? Yes or no? We can substitute RL. We know VM, we know frequency, we know VDC. Only the left term is capacitor. That's what they are asking, to calculate the capacitor. Okay.